What I am going to talk about is Java in the cloud, PaaS platforms in comparison. Let me say a few words about myself first. So my name is Eberhard Wolff. I'm Architecture and Technology Manager for Adesso AG in Berlin here. The office is at Warschauer Straße, not too far away. It should probably say leading IT consultancy in the German-speaking area. So we do have offices in Switzerland and in Austria as well. And we are among the 25 largest IT consultancies. I'm responsible for things like the training of the architects at Adesso. I'm also responsible for the technology strategy, so that's what I do. I am a speaker, as you can obviously see. I am an author. I wrote the first German Spring book. I do have a blog. Latest entry is about the waterfall model, everything you ever wanted to know about the waterfall model. I do have a Twitter account. You can find a lot of presentations at SlideShare, and for old-fashioned communication there's also an email address. Okay, so let's start with a general definition of cloud. There are three different types of clouds. As in the services that they offer. First of all, there is infrastructure as a service. That is basically just something that offers you, well, virtual bare metal, so to say. So it is, it provides you servers. They can be started quite quickly, so it's usually just a matter of a few minutes or even seconds. And it's quite similar to virtualization. The difference is that there is a self-service portal. So you can go to a portal, log in, start a server, and there is no manual process or manual labor involved. So that means instead of going to your operations department, asking them for a server and wait for, I don't know, a few hours, days, months, weeks, whatever, it will give you a server basically instantaneous. However, the problem, if you look at it from a developer's perspective, is that you will have to manage everything yourself. So it's just bare metal. You will have to install the operating system, application server, database, whatever, to make it in any form usable. If you look at some companies that provide services there's obviously Amazon Web Services. They have a huge offering around infrastructure as a service. We will see later on that it's actually more than just infrastructure as a service. And as one of the providers in the more private space, I've chosen VMware here. They are, well, they probably own the enterprise virtualization market. They do quite some cloud stuff. So if you're looking for a cloud that you can run in your data center, it's one of the companies that have an interesting thing to offer there. Then there is platform as a service. I think about it as a sort of an application server that you can just deploy your applications to, and everything else is done by the application server. It handles several issues that cloud has, like scaling out, so adding more servers depending on load, shutting down servers if there's less load, things of that nature. And it's mostly, that means the application is mostly managed by the provider. So instead of you having to manage the application and the infrastructure, you rely on the service of the platform to do that. Well, we will see quite a few examples. One probably, well, famous example might be the Google App Engine, which you can see the logo of in the upper left corner. It's probably like the original platform as a service, so that's why it's unique. And the other one that I brought is Cloud Foundry, which is an open source project. We will see a lot more about that later on. It's an open source project managed by VMware. And then there is software as a service. As a developer, it is probably some software that you're using, like, so I wrote an article over the weekend and did it using Google Docs because it's very easy to do it collaboratively on that platform. So, and that is software as a service because it's similar to all the other Office productivity suites that you can have. However, it's in the web. So that is something that you do as a developer. You probably use those. It might also be something that you want to integrate in your own applications. as a foundation for your application or things. like that. So examples. So there is the Microsoft Dynamics suite, which is a CRM system, customer relationship management system, that we are also using in several, for several customers. That is obviously something that you want to customize and that you want to provide additional services on. So that's an example. There is Microsoft Office 365, which is the Office running in the cloud. And there is another example that I think is quite interesting. It's actually one of our products. So Dribis is an application that we have created for insurances for juridical things. So what it does is, if you go to your Anwalt, lawyer, right? Sorry about that. So if you go to your lawyer, it actually takes your case and talks to the insurance whether that will be covered by the insurance. So that's what it does. And the special thing about it is that it's a platform and you pay it sort of per use. So you get an account and you pay it per use. So it's not a shrinkware product that you buy a license of. It is something that you pay per use. So it is in a way a software as a service, but it's very focused on a very niche market. And I think it's actually one of the things that we might see more of in the future, these niche applications provided as cloud services. So why would I care about cloud? I think the main benefit is flexibility. So as I said earlier, it's very easy to get a new server and to start a new server. It's an automated process. So there is no complex manual process. Instead, it's just automatically done. I think that's the main benefit. There is another benefit that is often spoken about, which is cost reduction. However, that is only valid if you look at public cloud, and it's actually more about economies of scale. So if you look at Amazon or Google, they have these large data centers, and of course they are able to operate those data centers at a lower price than your server sitting somewhere in some room. So I would argue that this is not necessarily unique to cloud. It is rather economy of scale. There is a special thing concerning costs and cloud, also for public cloud. So you just pay for the capacity that you're using at that very moment. So you can basically pay it by the hour or whatever. So that might be another thing, and that is actually unique to the cloud, that allows you to reduce your costs. For private cloud, so if you run your cloud environment in your own data center, I believe there is not too much of a cost reduction. You could argue that you might be able to consolidate your servers. However, you can also do that with virtualization, so it's not unique for cloud. So I think in particular, if you want to run your cloud in your own data center, the real advantage is around flexibility and not around cost reduction. So that might be something, well, special or something that is not too obvious if you talk about cloud in general. Why even talk about private cloud? Well, if you look at some of our customers, like insurances and banks, they obviously won't go for public clouds. Okay. So much for the introduction. So as a developer, one of the interesting questions is, how is cloud a challenge for me as a developer? There is a challenge concerning availability. So if you look at cloud and if you look at the terms of service that Amazon, for example, offers, it basically says, well, you know, individual servers might fail, even a whole data center might fail, and we don't take responsibility for that, which is very different from what you're used to if you're doing enterprise systems, because enterprise systems usually run on high available hardware, and failure of a service is usually a real nightmare. Here, the platform doesn't offer you any guarantees on how on the availability of the servers. Well, there are some guarantees, but they are pretty relaxed. So your system must survive the failure of individual nodes. There are applications like, there is this somewhat famous application called Chaos Monkey that just walks around and shoots different servers in the head, and the point is that your system must survive the fate of those servers. That leads to quite a few challenges and interesting architectural concepts. So one of the things that sort of emerge from the cloud are NoSQL databases that rely on a large set of servers, unreliable servers, and you scale out to scale to larger amounts of data, which is very different from what you're used to in relational databases, where you have single or just a few servers and you scale up by providing more powerful servers. So that is something. There are obvious things that we are probably used to, like you shouldn't have state on your web servers because they might fail. You could store the state of your web servers in a database or some centralized storage that is highly available. But generally speaking, it's more advisable to not rely on state on the web servers. So now this sounds a little bit, well, frightening, because basically the platform that you're working on is very shaky. But at the end of the day, if you look at systems like Amazon or Google, they are very, very highly available. And the reason for that is that, for example, you get a lot of data centers that your software can run on, which is otherwise quite hard. I mean, if you are an average company, you will have one data center, probably two. But if you look at Amazon, they have data centers all over the world. And even in each region of the world, they have multiple data centers. That is something that you couldn't afford otherwise. And that gives you high availability if you do your architecture right. Because if you do your architecture right, you can run your system in different data centers. And that way, if one data center fails, your system will survive. So you end up with a higher availability. And I think sort of the proof that this is true are the systems by Amazon, for example, that are highly available. And scaling. So if you look at scaling, as I said, there is pay as you go on the public cloud, so you just pay for the capacity that you're using. So you shouldn't size your system for the maximum load, because that doesn't make any sense, because then you would pay a lot of money, even though the load would be less than what you pay for. So you need to be able to start and stop servers depending on the load that you're seeing. And that again means that you have a lot of challenges. So you need to provide your system as a VM image, for example, so that you can run more and new instances, or some kind of automated installation, what have you. And we will see the talk later on about continuous deployment that I think might be a good solution for that. Okay, so platform as a service. As I said, this is basically around a sort of virtual application server that you just deploy your system on. So a lot of the challenges that we've seen are actually hidden from you by this platform as a service. So what are some benefits and some problems or challenges that those platforms as a service might have? If you look at the advantages first, as compared to application servers that we are probably all used to, they include a lot more. So it's a complete platform. Usually there is a database that you can also provision, there is some messaging system, and so on and so on. So I think it's actually a complete platform. I think that's one of the things. Then there are these issues that we've spoken about. So there is scaling. You want to scale up your system depending on load. If there is less load, you want to scale it down. Provisioning, starting new VMs, starting new instances, getting more servers. That is something that is done by your platform as a service. And fault tolerance, so restarting servers and dealing with failures on the hardware level. So that is another advantage. You can easily run quite a few environments. This is something in traditional software development that is hard. You need to do it. You need to have a test environment, you need to have a staging environment, you need to have a production environment, and you need to somehow make the code aware of these different environments. So you need to have a configuration that says, well, use this database or that database, depending on whether you're in staging or in production. Some of the platforms as a service allow you to do quite that just without any changes to the code or the configuration, because the platform offers all the things that you need, like the database, the messaging system, and so on. So it is easy to start a new environment and to provision a new environment, which is great compared to the nightmares that you otherwise have to just get a test environment up and running. Yeah, and it is easy to get something up and running. So if you want to run your application on the internet, on a proven infrastructure, and scale out to quite a few users, you can do it on the cloud, on a cloud platform, which otherwise would again be hard, because you would need to have some system in place, you will need to deal with scaling, and so on and so on, and the PaaS platform will certainly deal with some of those issues. So might be a good foundation for continuous delivery, and we'll see whether there is more about that in the next talk. So just starting new environments, getting new servers, that is very easy. And if you want to continuously deliver new releases, it is something that you probably need to host those releases. Okay, problems or challenges. There is a predefined package. So basically, if you look at the cloud offering, it says, well, we do have some environment, a Tomcat, some servlet environment, some additional services like a database and so on. So if there is a service missing, you do have a problem. And the same with fine-tuning the environment. So if you want to change the heap size of your environment, if you want to have a specific VM parameter, things of that nature, it might be a problem in your environment. So that is a challenge, and we will see later on that there are different trade-offs concerning that. And there are more dependencies, and there is a login. So if you get the complete package, it means that this package is usually available just from one source, and these proprietary services will lead you to a login. To be honest, I believe that even if you use standards in normal projects, so to say, you still have a login. So what I'm trying to say is, if you focus on avoiding a login, it will probably not work. Even if you have a standard Java EE server, for example, you do have a login concerning, for example, the operations side. So if you are used to one specific Java EE server and you switch over to another one, it will be hard because your operations department will see a completely different platform. So the question is whether there is a way to avoid login at all. And I would argue there is probably not a way. However, as we will see later on, there are real world issues concerning logins. Okay, so let's take a look at some of the platforms as a service that are out there. First of all, there's Amazon Elastic Beanstalk. And if you look at it, it's based on Amazon Web Services, which is the public cloud offering by Amazon. It's mostly infrastructure as a service. So there are virtual computers, that's EC2. There are elastic load balancers that also allow you to start new servers on demand and also shut down servers that are not used anymore because there's too little load. That is actually auto-scaling, so that's also part of the load balancing there. There is a simple storage service, S3, that you can use for large services like logs or your artifacts that you want to deploy, and elastic block storage for virtual hard disks. So if you look at it, it's a complete offering that gives you computers, storage, all these things, and also some auto-scaling. So that's quite nice. As I said, there is more than just infrastructure as a service on the Amazon cloud. So there is, for example, Elasticache, which is a turnkey ready memcached based service. So it gives you memcached caching without installation of any extra software or anything like that. There is RDS for relational database service for Oracle and MySQL. There is DynamoDB, SimpleDB, and so on and so on, and there are also quite a few third-party offerings that run on EC2. So there is one for MongoDB, there is another one for CouchDB. Those are NoSQL databases, and what this basically means is that there are predefined building blocks that you can build your application on. So if you look at, for example, RDS, it gives you a turnkey-ready relational database system, which otherwise you would need to install, to tune, to run on the cloud infrastructure, and so on and so on. And that is not too easy. So I mean, you can easily spend quite a few days installing a relational database and tuning it. And here you get it turnkey ready. There might be some tuning, of course, but still, I think this is quite an advantage of this platform. And in particular, the relational database services, at least for Java developers, are quite nice because that's usually what they are used to. So that's also something I think makes it quite valuable. So what is Amazon Elastic Beanstalk? So what it is basically they have taken EC2 to run the applications on, plus EBS for local storage, local hard disks, auto-scaling to start new instances if load increases, the Elastic Load Balancer to balance load between those started instances, and then a pretty standard Java stack, I would say. So Tomcat web server, Linux operating system, and OpenJDK as the JDK, and a nice web console to run your applications on. That is basically it. There are some alternative stacks that have been released recently. So there is PHP that you can run on top of it that uses Apache HTTPD, and you use the Git versioning system to deploy applications to the cloud. And there is also support for .NET that you could run on top of that. So that's quite nice. Yeah, so why would I use it? I think one of the advantages is that it's actually pretty standard. So if you look at it, it's what you're used to. Tomcat, Java servlets, standard system. It's also quite flexible. So if you want to tweak the operating system, you can do so. So what you do is you use the Amazon machine image, so the virtual machine image that is used by Elastic Beanstalk. You run it on some node, you do the tweaks that you want to do, and then you tell Elastic Beanstalk to use this modified machine image later on. So basically everything that you can do to your operating system, you can do here to fine-tune your system. So that means you can, change the Tomcat that is running, change the Tomcat configuration, you can change the virtual machine image, and so on. The foundation is proven, so Amazon Web Services is what Amazon runs its own infrastructure on. It's what Netflix uses and several other large companies. So that's quite stable environment. And there are other services. So there is a relational database, Oracle or MySQL, whatever you want to have. There are the other ones provided by some partners. You can install new versions of your software easily without any downtime. We will see that in a moment. And you can also, there is also versioning of the artifacts that you're deploying. And there is S3 for log files and all of those things. So it's basically a very nice combination of services that are already there, and they are provided to you turnkey ready, so it's easy to use them. Challenges? Well, it's currently in beta, so that means that you're basically out there on your own, so to say, if you run it in production. It's not available in all regions. So the way Amazon works is that it has separated the world into different regions. And currently it's only available in US East, EU West, and Asia Pacific. EU West is Ireland. That's also the nearest region that we have here in Berlin. So I think it's quite okay for European usage. There is no full support for Java EE, so it's just Tomcat. We will see later on that this is actually, well, very common. And well, in my opinion, running applications on Tomcat is perfectly fine, so that's not really a real issue. However, if you have a Java EE application, well, that might be an issue. It scales based on machines, so if you have too much load, it will start another machine. So that means if you're just above the range of one machine, you will get a complete new second machine that will be started and runs your application, which is, well, not that cost efficient because you need to pay each machine. But, well, if you just run your system on one or two machines, it's probably not worth the cloud anyway, and you shouldn't run it on one machine anyway because that machine might fail. So you will run it on quite a few anyway. So how does it work? To give you an impression, I've walked through the installation of a system using the console. Everything you see here can also be done using command line utilities, or there is a SOAP API that you can also use. So if you want to automate things, that's perfectly possible. To give you an impression what is possible, it's probably best to walk through the slides. And also, I mean, one of the things that I think is quite nice about Amazon Web Services is the sort of out-of-box experience. So if you have signed up for an account and you go to the Elastic Beanstalk page, it welcomes you with this nice interface, and it says, well, do you want to launch a sample application or your own application? So, and if you just launch a sample application, you're basically up and running in a few minutes. But we are going to raise the bar a little bit and upload your own application. So we will give it a name and upload a WAR file, as you can see here. So that's Beanstalk demo-war.war that we are deploying. In the next step, we will create an environment. So an environment is some collection of servers that your application runs on. It has a URL, as you can see, and you can choose different container types. So in my case, I'm using 32-bit Amazon Linux running Tomcat 7. You might also use Tomcat 6 or 64-bit Amazon Linux, or the PHP or Windows .NET versions of the environment, of course. Then you can change your configuration details, so you can give an instance type. There is so that's the size of the computer that you're running on. You can have a key pair. The key pair allows you to log into the running system and change it later on if you want to. And provide an application health check URL, which might be useful if you have a specific URL that the load balancer should go to see whether one instance is still up and running. And then you're basically good to go, and you can start the application. And what happens is that an environment will be started. So that's the Amazon Adesso Beanstalk environment that is currently starting. After a while, you will get the green light and the application is available at that point. So you can go to the URL that you've configured and you will be able to hit the application at that URL and you're done. And if you scale up the application, there is a default configuration, so it will start new instances, and you can easily scale it up. You can also change the policy, the scaling policy, so there's quite some flexibility there, and do that. What you can do as a next step, so what I'm doing now is I've decided to upload a new version of my system. So I've chosen to upload a new version. The version will be called 2.0. And at this point in time, I won't deploy it to any environment. I could choose to deploy it to the environment that is already running, but I don't do it. So now I have two versions at the top. And so that means those two wars are somehow stored in S3 and are available for environments to use. So as a next step, I will start a new environment. I will call it new Adesso Beanstalk. and deploy the new version 2.0 to that environment. And well, that's an old story. So after some time, the new environment will be there. I can now test it, see whether it's working the way I expect it to work, and well, publish the URL to some guys and tell them to test it as well, and so on. And once I believe that this version is fit, I can swap the environment URLs, and when I've done that, then so I now say, okay, please swap those two URLs. And once I've done that, the new version is available and running without any downtime, because all I did is I changed the system behind a specific URL. So that I think shows you what you can do. It's very easy to deploy applications. It gives you scaling, it gives you updates of your system without any downtime, and so on and so on. So, and you can do that, well, by mouse, or if you are a real developer, you will probably do it with the command line utilities or some automated scripts or whatever you have. Okay, I won't show the other ones in that much detail. They do differ, but this is just to sort of give you an idea of how easy it is to really get started of one of those environments. The other ones are not that much harder. They differ in terms of features they have, but I think this shows what you can do using a PaaS approach. Okay, so next in line is Google App Engine. What is it? I think the role that Google App Engine plays is the role of a pioneer. So it has been very early in the market. It has been one of the first available platforms as a service out there. It has support for Python, Go, and Java. Go is a language that Google themselves introduced for systems programming. It's a public cloud only. Amazon Elastic Beanstalk is also a public cloud. In a way, it's a true PaaS. So that means, as compared to Amazon Web Service, Amazon Elastic Beanstalk, where you could actually tweak the machine, log into the machine, and do whatever you want with those machines, this is off limits in Google App Engine. In Google App Engine, it's a complete abstraction. So you just have your system, and you don't even see that it's running on a web server or on an operating system. That's all abstracted away. That means, so there are limited possibilities in terms of what you can do for tuning. So there is no way that you can change VM parameters or anything like that. That's just not possible. It is ready for production. So Amazon Elastic Beanstalk is still in beta, but this is really released software and is used in production at several companies or several systems. There are some additional services. So there is a NoSQL key value store that you can access using JDO or JPA. JDO is the older persistence standard. JPA is the more recent one. To be perfectly honest, I think it's not a perfect fit, because JPA is obviously something that is specific for relational databases that relies, for example, on joins if you want to have the full capacity. And obviously you can't do quite a few things on a NoSQL store. So I think the benefit that you get is that if you're used to JPA, it's not too hard to use this NoSQL store, because it's, a similar API. However, in terms of portability or using different persistence engines, you will probably have a hard time converting things from Google App Engine to a different environment. There is a database called CloudSQL that is in preview right now. It's MySQL based, so it's very much like MySQL, but it's only a preview at this point. And there are quite a few other services. So there is a caching service, a blob storage service. There are services for image manipulation, XMPP chat, and so on. So the point here to note is, It's limited, so there is just a NoSQL store, and in particular, there is no relational database available if you talk about a production-ready system. So there is the preview, but I'm not sure whether I would use it in production. Yeah, so what are some things on the roadmap? So, well, outbound socket support to talk to other services. This is not possible right now, so it's not possible to open up a net connection to some other services from Google App Engine. There is support for the Java. There will be support for the Java Servlet 3.0 API for asynchronous transfer, MapReduce API, and Blobster migration tool. So advantages. Well, it is stable in production, and there are quite a few people using it. And of course, as it's running in a Google data center, there is quick access to other Google services. There is a nice integration with Android, so I think a common use case for Google App Engine is to run the backend of Android applications on that system. It is free for small applications, and as I say, it's a very fine-grained model for scaling. So basically you pay by request, which is different from Amazon Web Services. So those are the advantages.
One question.
Sure.
What means small applications exactly?
So there are certain limits in terms of the capacity that you're allowed to use. They are actually not that low. So if you have something that is not enormously successful, you can basically run it for free. And I don't know the details from the top of my head, to be perfectly honest, but you can sign up for it, and it gives you nice information about the concrete limits. Okay, challenges. Data centers in the US only, which is not too great if you're in Europe, of course. And not just because of data privacy, but also because of latency. There is a very limited wide list of classes that you can use. And there are nice articles that talk about how you can actually run JSF on top of Google App Engine, which is probably a technical challenge that I wouldn't like to solve, because I assume that, web framework just works. So that is a problem there. I'm not too sure about the other languages like Python or Go, but this is really, in my opinion, a severe limitation. And it's a whitelist. So it doesn't say, well, here are some classes that you cannot use. It says, here are the classes that you can use. This, in a way, leads to a lock-in. So if you look at it, there is the JPA API to talk to the NoSQL store, which is very specific for this NoSQL store if you want to run your applications in a performant manner. You will have specific classes that you're using. There are specific services that you're using. Supporting an application from Google App Engine will probably not be that easy. And for some reason, they changed the pricing not too long ago. And that caused quite some, let's say, confusion among the developers. And I think that's actually not a pleasant situation to be in, because you're basically locked into this specific environment, and then all of a sudden pricing is changed, and there is no easy way to get away from that platform. So I think those are some problems. As I said, it's a very restricted environment. There is a limited sandbox. There is the focus on NoSQL databases. There is a limit on the startup time for applications. There is a limit on the response time. There is no way that you can access the operating system, which I call the true PaaS in a way. And you can't even access and fine-tune the web server. So, and there are even specialized frameworks for Google App Engine, such as Gaelic for Groovy, that just focus on Google App Engine, which in my opinion, again, shows that there is some kind of lock-in. Of course, there are standards. Of course, you could probably migrate a system away from Google App Engine, but at the end of the day, there is a lock-in. And I said before that login is probably not something that I'm too afraid of. What the real problem is, in my opinion, is that this platform is not like a real Java platform, because it has this very limited set of whitelisted classes. So Google App Engine. Then the next one is Cloud Foundry. What is it? It's an open source project led by VMware, and it's Apache license. So Apache license basically means that you're free to do whatever you want to do with it. So you can even create your own fork and sell the software. And I think that is very, very interesting. If you look at the other platforms, they are closed source. I mean, of course, they do incorporate open source projects, but there is no way that you can run the Amazon Elastic Beanstalk infrastructure in your own data center. Same thing for Google App Engine. This platform here actually gives you the ability to do so. And there is a community that has built its own systems around this core. So one of the goals of this system is to become the Linux for cloud, so to say, or for PaaS. And there are other commercial offerings around Cloud Foundry at this point. There is a public cloud by VMware that is in beta. There are private offerings, so there is active state Stecto that you can use, and there is another one that has been announced by VMware on some forums, so not a very public announcement, but if you look at the forums, it actually says, well, we do have plans to provide a private offering. And there is a microcloud that allows you to run a reduced version of the cloud on your own laptop, basically, to test things and to run your system in your own environment. Yeah, there are quite a few languages that are supported: Java, Scala, Groovy, JVM languages, but also Ruby, Erlang, Node.js, Python, and PHP. And that is another nice benefit of open source. So there is a community, and they add features like language support, for example. So that's nice. And there is, it's a PaaS, so it is between, I would say, Google App Engine and Amazon Elastic Beanstalk. So you can do some tweaking. So for example, you can configure the memory that is reserved for an application, but that's it. So there is no detailed tweaking as you have it in Amazon Elastic Beanstalk. Yeah, so other things, there is support in Ubuntu and Ubuntu UU to provision systems running Cloud Foundry. There are images for Amazon EC2 provided by RightScale. They haven't been updated for quite a while. There is a .NET port, Iron Foundry. The VMware guys have recently released Bosch, which is their system to provision servers at cloudfoundry.com. So there is a whole ecosystem and quite a few partners that are building their business around Cloud Foundry. One thing that is very specific to Cloud Foundry is these services. So if you look at the other, what that means is that Cloud Foundry will provide access to the application to specific services, like RabbitMQ, PostgreSQL, MySQL, Neo4j, Redis, MongoDB, and so on. And your application will get the reference to the service from the environment. So usually what you do is you write your application, you say, okay, there is a URL, a JDBC URL for the database, and you need to configure it. That's different here. So what happens here in your code is that you go to Cloud Foundry and say, well, I need a database. And then Cloud Foundry says, well, there is this PostgreSQL server around here that we are all using. So why don't you use this? And here is your URL, here's your username, here's your password. And that means that you can run the system or the application unchanged in different environments, which is nice for staging, testing, and so on. To do that, you need an integration in the framework. So there is, for example, the cloud namespace in Spring that allows you to say, well, I need a reference to a database here. Similar things, there's an automated configuration in Spring as well. So if there is just one data source, it will be overwritten by the data source that the Cloud Foundry will provide. Other frameworks supported are Play and Lift, or you can use API calls. So the way it works behind the scenes is that when your application starts, there are environment variables that contain the information of the configured services, and you need to read out those environment variables, and then they will contain the URL, the username, the password, all these things, and then you can use your normal approach to access those services. Or you use the framework integration, which is, of course, much easier and nicer to use. So, why would I care? What's the advantage? Well, I think there is a lot of open source innovation happening in this space, so that's interesting. And there is a private cloud story. So if you look at the other offerings, they all focus on public cloud. And as I said earlier, there are banks, insurances, and so on that will probably never run their system on public cloud. If they still want to have the flexibility of a PaaS solution, they can use Cloud Foundry. There is the microcloud for laptop and desktop testing, and there is the services model, which is unique to Cloud Foundry. So services injected in your application, basically. There are some optimizations. So if you upload your application, all the libraries will be cached. So instead of uploading the complete WAR file with all the dependencies, just your code will be deployed automatically behind the scenes. Servers for databases are shared across all applications, so it won't start your own application, your own database server, which is again quicker and also probably more cost efficient. And it's again the standard programming model that we are probably all used to. Tomcat for Java, the standard environment. Challenges? Well, first of all, the public cloud is in beta and there is no pricing announced. Private cloud is in beta or is available but not from VMware. There is no full support for Java EE, so it's limited to Tomcat. As I said earlier, I don't believe this is such a big issue, but well. Data centers are only available in the US. However, you could run it on EC2 and install your systems on EC2. Integrating additional services is in principle possible. However, you would need to change the code base. So if you want to rely on Cloud Foundry and Cloud Foundry's service model, you would need to actually change the code base of Cloud Foundry itself, which is, well, probably complex. So that means there is a limited set of services. So if you look at Amazon Elastic Beanstalk, basically every database that is running on EC2 can be used from Elastic Beanstalk. It's just that you have to have the traditional configuration mechanism, while here there is an automated configuration mechanism, but therefore the choice is limited. And you would need to provide integration in your framework. Another problem, if you run Cloud Foundry on your own system, it's actually quite a complex piece of software because there are all these services that are integrated. And the other problem is, so how are those services scaled? I mean, if you want to have PostgreSQL or MySQL running in production, you want to have a bulletproof installation that is also able to scale. And probably that will be different from the standard installation that Cloud Foundry offers. So that's a challenge. And there is a problem because if you add a new service, you probably also need to have integration into all frameworks. So if you have X frameworks and Y services, then you have X times Y many integration points, which is, well, not too great. Okay, last in line. Again, I think a completely different approach is Cloudbees. Cloudbees has actually two offerings. So there is DevEd Cloud, which I believe is probably the thing that makes Cloudbees very interesting and also sets it apart from the competition. DevEd Cloud are developer services. So it's a continuous integration server that checks out your sources, compiles them. There is a Maven repository for snapshots and releases. There are Subversion and Git repositories, and there are also some partners for testing, static code analysis, wikis, and so on and so on. So basically, you get, except for the IDE, you get everything that you need to run your project, which is nice, and it's also quite different from the other offerings because they focus on production environments or environments that your system can run on. There is a RunatCloud environment that uses EC2 and Tomcat on top of that. It's very easy to deploy a WAR file. There are some configuration options. One specialty is that there is support for the Java EE web profile. So all the other competitors that we've seen so far are only able to support servlets. They actually provide support for the web profile, which is more complex. There is support for elastic scaling, for monitoring. There is a simple MySQL database. You can also use Amazon RDS, of course, and there are also partners for other services. So that's RunatCloud. Advantages, well, it's production ready. So they have left the beta status for quite a while now. And they also support the development process. And they have more than just servlets. They have the web profile. And this is in a Java programming model. It runs on top of EC2, so you have access to all the other things that Amazon Web Services has to offer. Challenges, well, RunatCloud is not that, doesn't really have that much flexibility in terms of configuration. So I think that is the main problem. So I think the way it is positioned is as a system that supports developers. That's the main point. I'm not sure whether, and the RunatCloud offering is, well, separate and probably not, in my opinion, not the focus. Cloudbees might disagree, not sure. So there is Heroku, that's a PaaS that is now owned by Salesforce. Previously, Salesforce had a collaboration with VMware. That is now more or less a thing of the past. Supports Java, however, as a beta only, and also only in US data centers. And it's different because the way it works is that you push your source code to a Git repository. It's automatically compiled by Heroku and run on their cloud platform. It's very popular among, I would say, Ruby developers in particular. And well, it is sort of starting or has a Java offering out there for a while now. Then there is Microsoft. It's primarily targeted at .NET, but there is also Java support. The reason why I've included it in the presentation is because it's, again, they have worldwide data centers, much like Amazon. They are production ready. They have a very complete offering. So they have a relational database service. They have a NoSQL service as well. They have caches and so on and so on. They even have support for Linux workers now that has been announced, I think, this week. And they have a turnkey ready Hadoop solution, as has Amazon. So the reason, as I said, why I've included it is because I believe if you look at Azure, it's probably the other system that is available worldwide and is really interesting and second only to Amazon probably. Yeah, Oracle Public Cloud has been launched this week based on their suite. And there is also Red Hat OpenShift. They have a complete Java EE offering again. So that's another thing that you might want to look at. However, I don't want to dive into details there. Pricing. Yeah, that's interesting. So the bottom line is it's very hard to come up with numbers. So the models are very different. And you can't come up with an estimate that says, okay, your application will cost this on that cloud environment and that on this other cloud environment, because the way the charges are calculated are very different. If you look at Amazon, for example, it's based on the number of instances that you're running and how long you're running them. If you look at Google App Engine, that's completely different because they don't even have instances, so they can't charge you for instances, of course. Yeah, so that concludes my presentation. I hope you got a nice overview about all the different offerings, and I would be happy to ask questions if there are any.
So first, how does it integrate? So some of those cloud offerings, they are directly integrated into the development process. Yeah. So I know from Spring, from the VM where joiner there, that is also an offering for the development process. So I mean, we use Jenkins, Hudson, and all that stuff. Are there plugins available for all those cloud offerings, or is it? So I mean, as you said, yeah. So I have multiple environments. I have testing, I have development, I have staging, and so on. So it would be good to have different environments as well. Is there any support?
Yeah, so usually there is some sort of command line utility that you can use. So if you look at Cloud Foundry, for example, they have this BMC command line utility that you can use. Same thing for Elastic Beanstalk. They also have an API that you can use. Same thing for Cloudbees, and for Google App Engine, I believe there is also something like that. Also, all of them do offer Eclipse plugins. So there is an Eclipse plugin for Cloud Foundry, there is one for Elastic Beanstalk, and there is one for Google App Engine. I believe there is none for Cloudbees, to be honest. And if you look at Cloud Foundry and Elastic Beanstalk in particular, it's just like your Tomcat. So it basically says, here is the server, deploy stuff to it, and you're done. So that's actually quite nice and convenient in a way. If you talk about support for like the real development process, like Cloudbees has to offer, there is this announcement by VMware together with TaskTop about GOTO Cloud. I'm actually not really sure about the status the status there. It seems to be a really early announcement, so I'm not sure whether they are following up. And as I said, I believe that Cloudbees is actually quite uniquely positioned in that regard. And they have the Jenkins committer on the payroll, so I think they're doing quite nice.
I have a question to the Google engine. You said that you may use JPA, for example, but no joins are allowed, and you may not have a relational data model. So does it mean that the design of your application is also restricted? You may not have a complex object model, because usually you have a complex object model and you transfer it to a complex data model. And that is not possible, or how do I handle this?
Well, I mean, the point is that on a NoSQL database, you can't really, well, or on these kinds of databases, not NoSQL in general, you can't do joins, because that would mean that you would need to, that all servers need to talk to each other, and that is not feasible. So yes, there are limits. You could still come up with ways to navigate from one object to another. However, it will be different from what you're probably used to. And as I said earlier, I believe that is one of the issues that Google App Engine has. It's not to say that you can't run complex applications on top of that, because obviously, I mean, you can, it's just different. But it's also different from what you're used to, because most of the Java developers are actually experienced with the relational database model. And the question to me is also whether there is, so it's sort of a price that you pay. Question to me is, what do you get? And if I look at it, and if I'm honest, I'm not sure what you get, because it is, well, there is a different pricing scheme, so you might be better off concerning pricing. But there are so many technical, well, challenges if you come from a traditional Java background, because there is this whitelist of classes, there is a NoSQL database that's different from what you're used to, and there's also a login. So to me, the question is, why would I use it? The only point that I can come up with to me is this integration with Android. So that seems to be a good thing. Maybe if you want to run simple applications and if you stick to the free tier, that is also something that might be valuable. But otherwise, I would probably not use it. And the reason why I've included it in the presentation is because a lot of people, and in particular from a Java background, believe that PaaS and cloud is like Google App Engine, and actually it's not. I mean, there are even people who, so I had a discussion online somewhere, and there was this, the guy basically said, well, you know, if you want to have a true cloud, it has to be like Google App Engine. You have to abstract away from the operating system. You can't touch the web server, and you have to use a NoSQL database. And I think that's just wrong, and because there are other offerings that have a different trade-off there.
Do you have some figures about the market share in relation to Java runs?
No. Ooh, no. I have no idea. I believe that it's, let's say I believe it's rather at the starting point. If you look at it, most of the stuff that is done is still, I mean, it's an enterprise technology. So usually what happens is that the stuff runs in your own data center. There's a lot of interest, and with the announcement by Oracle this week, it's pretty apparent, and also, I mean, cloud is supposed to be one of the major subjects for Java E7. I won't talk about why I believe this is actually not that true, but that's a different subject. But it is on the radar screen of quite a few people in the Java scene, and there is a lot of investment going on, as you can see. So I think there are things going on, but at the same time, I would say it's still the traditional application server model in your data center that we're seeing most of the time. Okay, cool. Thanks a lot.